Hi everybody, today we're going to be doing section 8.4 day 2. It's our second day of trigonometry. We're going to be reviewing some of what we learned in section 8.4 day 1, and then we're going to be adding a couple little twists to that. So as a quick recap, there's 3 trigonometric ratios: sine, cosine, and tangent. And the main thing that we learned is how to identify which side would be opposite of the angle we're working with, which side would be adjacent to the angle we're working with. So for instance, let's say we're working with angle A, and let's say we want to find the sine of A. Well, if you remember, sine is opposite over hypotenuse. So we have to think, well, what side is opposite of angle A? Oh, that'd be little a. And what side is the hypotenuse? Well, remember, the hypotenuse is always across from the 90-degree angle, so our hypotenuse is C, so the sine of A would be A over C. All right, so before you try this one, I want to give you a quick reminder of how to remember the trigonometric ratios. Don't forget we talked about SO, CA, TOA, and this was a mnemonic device that we used to remember how the ratios went. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Go ahead and pause this slide and try to find the sine of t, the cosine of t, and the tangent of t, and when you're done, unpause. So remember, sine is opposite over hypotenuse. Well, we're working with angle T, so opposite of angle T is 7. This would be the opposite side. Hypotenuse, of course, is the longest side. It's the 25. It's also across from the 90-degree corner. That leaves 24 to be the adjacent side. And remember, adjacent sides always are going to come up and touch the angle, just like the hypotenuse, but it's the other side that touches the angle. So sine of t is opposite, which is 7, over hypotenuse, which is 25. Cosine of t is adjacent over hypotenuse, so 24 over 25. And tangent is opposite over adjacent, so 7 over 24. Hopefully you did okay on those. So this is again a recap of what we talked about on that last lesson, 8.4 day 1. In this case, they want us to find BC. That means find the distance from B to C. I'm just going to call that X for now. It'll be easier to write in the equation that way. So what I do is I look at the angle we're working with. Remember, you never use the 90-degree angle. You always use some other angle other than 90. In this case, we're given angle 64 degrees. X, the side that we want to try to find, is opposite of that angle. 13 is the other side with writing on it. 13, is that adjacent or hypotenuse? If you thought adjacent, then you are correct. So now I want you to go back and think about SOHCAHTOA. When you think about SOHCAHTOA, you have to decide which one am I going to use. Am I going to use sine, cosine, or tangent? Well, in this case, we have an O and an A. So you're going to look for the trigonometric function that has the O and the A. Here it is. The O and the A are together with T, TOA. T stands for tangent. So we're going to go tangent. Always after the function, you're going to put the angle. So in this case, it's tangent of 64 equals, and then it has to go in order. This middle letter goes on top. The last letter goes on bottom. And so opposite would go on top, which is X, and adjacent would go on bottom, which is the 13. Solve this for X. To solve it, you're going to just multiply by 13, or 13 over 1, and then you're going to get your calculator and you're going to type in 13 tangent 64. Now, if your calculator is in the correct mode, you should get 26.65. So go ahead and try that. If you're not getting that, your calculator might not be in the right mode. And so you might have to actually find the button that says mode and change your mode to degrees. Your mode definitely needs to be in degrees because our angle is getting measured in degrees right now. One last thing, notice up here they asked us to find BC, so I guess technically I should write BC equals 26.65. They do have a label. The label is meters, so I want to make sure I label as well, and then that is our final answer. So I said there would be a couple new twists today. So here's one of the new twists. We start out the same. It says find x, so we want to solve for x. Start with the angle that's marked that's not 90. In this case, it's 47 degrees. Identify two sides that have writing on them. So the x is the adjacent side. It is right next to our angle, but it's not the hypotenuse. And the 19 is the opposite side. So think about opposite and adjacent. If you have so, ka, toa, and you want to pick the one with the A and the O. Again, that's part of toa, which is tangent. So we're going to go tangent of, what always comes after the word? The angle, so 47 degrees. So tangent 47 equals, then you have to think, what goes on top? If you're thinking 19, you're thinking correct. And then adjacent is on the bottom, so x is on the bottom. Here's where it differs from the ones we did last time. This time, we can't just multiply by 19. If we multiply by 19, they're not going to cancel out, so we can't do that. And so instead, what we want to do is we want to multiply by what's in the denominator. So we're going to multiply by x, or think of it as x over 1. But whatever you do to one side, you have to do to the other. So bottom line is multiply by whatever's on the bottom. These will cancel out. So we're going to have x equals, or x times tangent 47 equals 19. But remember, we're trying to solve it for x. Right now it's x times tangent 47. How do you undo a times? You divide. The opposite of multiply is divide. So we're going to divide by tangent 47 on both sides. Whatever you do to one side, do to the other. These will cancel out. And so you're going to be left with x equals 19 divided by tangent 47. At this point, you can just grab your calculator, type in 19 divided by tangent 47. Go ahead and do that. If you're doing it correctly, you should get 17.72. And again, there is a label. It's meters. If they label, you should label. Cool. So before we try this one, I want you to think about this. Could we do this problem with Pythagorean theorem? Could we use a squared plus b squared equals c squared? And the answer is no, because to do Pythagorean theorem, we need to have at least two of the sides of a right triangle. So up until section 8.4, we wouldn't have been able to solve this problem. We wouldn't have had a method. But now with SOHCAHTOA, with trigonometry, we have a method for solving this. So go ahead, pause here. Go ahead, pause the video and try this problem. And then when you're done, check and see if you get it right. So hopefully you're back. You've tried it. So here's what I would do. Here's your angle. You're working with a 61. 22 is opposite of the 61. X is the hypotenuse. Think about SOHCAHTOA and pick one. You need the one with the O and the H. The O and the H are right here. They go with SO. S stands for sine. Sine. After the function, you always put the angle. So sine of 61 equals, opposite has to go on top. So it's 22 over x. Solve this by multiplying by whatever's in the denominator. In this case, we're going to multiply by x. They cancel out. And then you have to get x by itself. To get x by itself, right now we're multiplying. So the opposite to get it by itself would be divide. So we're going to divide by sine of 61. These cancel out. And you're left with x equals 22 divided by sine 61. Grab your calculator, type it in. You should get 25.15 feet. Boom. Nice job. So here's the second twist. Take a look at these problems. It says find the measure of angle A. So this time, instead of trying to find one of the missing sides, we're going to try to see if, based on the lengths of the sides that were given in this right triangle, can we find a missing angle? And the answer is yes, because all triangles with two angles that are the same have ratios that are similar. And so because we know two of the sides, we know the ratio between those two sides is 18 to 27. And based on that ratio, we're going to be able to discover how big this angle should be. So just like before, we're going to start the same way. Whatever angle we're working with, we're going to start there. In this case, we're working with angle A. Now, based off of angle A, we have two sides with writing. One of them is the 18. The 18 is opposite of angle A. The 27 is the hypotenuse. So I want you to still think about SOHCAHTOA. And you're still going to pick one of these ratios. We have O and H. So see if you can pick which one we would use. If you picked sine, then you are correct. So we're going to go sine, but we don't know the angle. So instead of filling in a number, we're going to fill in just the letter A, the angle that we're looking for. And it equals opposite over hypotenuse. So 18 over 27. Now to solve this for A, it's a little different. This is not saying sine times A. It's saying the sine of A. So to get A by itself, we have to get rid of this word sine. And to do that, we use what's called the inverse sine. And so on your calculators, you'll notice right above the sine, the cosine, and the tangent button, you're going to see a little inverse sine, inverse cosine, and inverse tangent. They have a little -1 up there as an exponent. It's basically saying the inverse of sine is the opposite of sine. They cancel each other out. So if I take the inverse sine, it's going to cancel out the word sine. But remember, when you're solving an equation, whatever you do to one side, you also have to do to the other side. So what happens on the left is these cancel out and you're left with just A. But on the other side, we have the inverse sine of 18 divided by 27. This is what we're going to type into our calculators. In order to do that, you're going to use the second button. You're going to type in second and then sine. Oh, that's not great writing. Let me try that again. You're going to type in second, which is going to be, a button towards the top of your calculator. And then you're going to type in sine. And then it's going to give you a parenthesis. You're just going to type in 18 divided by 27. And then hit equals or enter, and if you did it correctly, you should get 41.81 degrees, and that is the measure of angle A. Pretty cool. We could figure out how big that angle is. Okay, let's try another one. This time, let's find the measure of angle T. Remember, this little M means measure. So we're going to be working with angle T. Two of our sides have writing. The 8. The 8 is opposite of our angle T. What's the 12? Is the 12 the adjacent or the hypotenuse? If you said adjacent, you are correct. So now think about SOHCAHTOA. You're looking for the function that has O and A. O and A, go with TOA. T stands for tangent. Tangent of what? Well, we don't know the angle, so we're going to have to put the letter. So tangent of T. And then it's opposite over adjacent, so 8 over 12. Remember, it's not tangent times T, it's tangent of T. So to get rid of the word tangent, you have to do the opposite, which is the inverse tangent. Whatever you do on one side of the equation, you do to the other. Here they cancel out. You're left with just plain old T. On the other side, we have the inverse tangent of 8 divided by 12. You're going to type that in your calculator. You're going to type in second, tan 8 divided by 12 equals, and hopefully you're going to get that the measure of angle T comes out to be 33.69 degrees. And that should be the size of angle T. So for this last problem, we're going to find all the missing parts of the right triangle. Sometimes it will say solve the right triangle. What that means is you have to find all the missing sides and all the missing angles. In this case, let's start by finding side FH. So we already know two sides of a right triangle. We don't actually need to do trigonometry to find the third side. We can go back to Pythagorean theorem. So take a minute, go ahead and pause the video, try to do Pythagorean theorem to find FH. You might want to call it X as you solve it. Go ahead and pause. All right, so hopefully you decided that 13 is the hypotenuse. And so when you set this up, you maybe went x squared plus 5 squared equals 13 squared. 13 has to be your C. It doesn't really matter what comes first between the x and the 5. So here we have the math behind it. X squared equals 144, and then you take the square root, and x equals 12. So pretty cool. This side of the triangle is 12. Next, you have to decide which angle you want to find first, either angle F or angle G. In this case, it doesn't matter which one you choose. I'm going to randomly choose angle F. If I want to try to find angle F, I'm probably going to have to use trigonometry. Now, I know I have all three sides, but since they gave me the 5 and the 13, it's probably a safer bet to use their numbers in case I screwed up the 12. So from angle F, think about what two sides the 5 and the 13 are. Well, I already know the 13 is the hypotenuse. The 5 is opposite of angle F. And again, I just randomly decided to choose angle F to find first. So think about SOHCAHTOA. If you have SOHCAHTOA, and you want to find angle F, and you have opposite and hypotenuse, O and H, you're going to choose SO. S stands for sine, so sine of, oh, we don't know the angle, so we'll just say angle F is opposite over hypotenuse. How do we get F by itself? Well, it's sine of F, and so we have to do the inverse sine on both sides. That way it'll cancel out the word sine. And F will be the inverse sine of 5 divided by 13. Go ahead and type that in your calculator. You'll have to do second sine 5 divided by 13. And if you do it correctly, it should be 22.62 degrees. That is the measure of angle F. All right, then to find angle G, we have some choices. Now that we know this angle is 22.62 degrees, remember in a triangle, the three corners always add up to 180. So it's probably fastest to do 180 minus the 90-degree corner, minus the 22.62 degrees, and what remains is 67.38 degrees, and that is the measure of angle G. Cool, so now you guys should practice. Tonight's homework is 8.4, day 2. Good luck. If you have questions, feel free to send me a Schoology message.